Hi everyone. This is another one problem from Gauss Quadrature. So in this question, evaluate the integral double integral minus 1 to 1 minus 1 to 1 2 x square plus 3 xy plus 4 y square by using dx dy by using Gauss Quadrature. But in this question, it is not clearly mentioned by using 2-point Gauss Quadrature or 3-point Gauss Quadrature or 1-point, 4-point. It is not mentioned. So here we go to find by which method, by Gauss 2-point or 3-point, which one is best for this problem. Here we go to find. So in this question, the function is x and y, that is 2x square plus 3xy plus 4y square. X and y, there is a two function, therefore here f of x y equal to 2x square plus 3xy plus 4y square. So therefore here order of polynomial equal to order of polynomial equal to 2n minus 1, that is 2n minus 1 equal to, here which one is the highest degree? X square, so 2 is the highest degree, and y square, so 2 is the highest degree of this problem, therefore 2n minus 1 equal to 2, therefore 2n equal to 2 plus 1 minus 1 plus 1, therefore 2n equal to 3, n equal to 3 by 2, that is equal to 1.5, approximately 2. So therefore n equal to 2, therefore here we use Gauss 2-point formula. So therefore Gauss 2-point formula, Gauss 2-point formula for double integration, that is integral of minus 1 to 1 f of x comma y dx dy equal to w1 square f of x1 y1 plus w1 w2 f of x1 y2 plus w2 w1 f of x2 y1 plus w2 square f of x2 y2. So you put this is equation 1. So 2-point formula, therefore x1 equal to root of 1 by 3, that is equal to 0.57735. So therefore similarly y1 also 0.57735. x2 equal to minus root of 1 by 3, that is equal to minus 0.57735. y2 similarly y2 equal to minus 0.57735. w1 equal to 1, w2 equal to 1. Here f of x comma y equal to 2x square plus 3xy plus 4y square. Here we go to find for f of x1 y1, that is equal to f of 0.57735 comma 0.57735, that is nothing but, so before that here what is f of x1 y1, that is f of x comma y equal to 2x square plus 3xy plus 4y square, therefore f of x1 y1 equal to 2x1 square plus 3x1 y1 plus 4y1 square, therefore f of x1 y1 is x1 equal to 0.57735 comma y1 equal to 0.57735. It means 2 into 0.57735 square plus 3 into 0.57735 into 0.57735 plus 4 into 0.57735 square, that is f of x1 y1. So here by using calculator here we set the formula first, so that is 2 plus 2x square, so 2 alpha x square, 2 alpha x square plus 3xy. So 3 alpha x alpha y plus 4 alpha y square, alpha y square. Then press calc button. Here x value equal to 0.57735. So press x equal to, press calc button, x equal to 0.57735. Then press equal to, then type y value. Y value equal to 0.57735. Then press equal to, value is 2.9999. So therefore that is equal to 2.9999. Point next we use 4 digits. Next one, f of x1 y2, f of x1 y2, that is equal to f of 0.57735 comma minus 0.57735. Then the value will become, press calc button, x equal to 0.57735, y equal to minus 0.57735, that is equal to 0.9999. f of x2 y1 equal to f of minus 0.57735 comma 0.57735, that is equal to, press calc button, minus 0.57735, y equal to 0.57735, that is equal to 0.9999. Then f of x2 y2 equal to f of minus 0.57735 comma minus 0.57735, that is equal to, calc button, minus x equal to minus 0.57735, y equal to minus 0.57735. So that is equal to 2.9999. Therefore substitute in equation 1 you will get, so integral minus 1 to 1 minus 1 to 1 f of x comma y dx dy equal to w1 square, w1 square equal to 1 square, 1 square into 2.9999 plus w1 w2, that is 1 into 0.9999 plus 1 into 0.9999 plus 1 square into 2.9999. So next line, that is minus 1 to 1 2x square plus 3xy plus 4y square dx dy equal to 7.9996. So this is the final answer. Thank you.